I'm going to record the solutions and the work and kind of talk you through the College Algebra Final Exam study session examples for version 2. Number 1 says to find the domain of y equals the square root of quantity 4x plus 7. You're going to take what's underneath the radical and you're going to set it greater than or equal to 0. When you do that, you need to get x by itself on the left. So first thing I'm going to do is subtract 7 from both sides. That leaves me with 4x greater than or equal to negative 7. To isolate the x, I need to divide both sides by 4. Since I'm dividing by a positive number, I do not do anything to the inequality, and I get x greater than or equal to negative 7/4. On the number line, equal to means it's a filled in circle. Greater than, I want to shade to the right. So to put that into interval notation, I want to bracket negative 7/4, comma infinity with a parenthesis. That is my domain. For number 2, find the equation of the line that passes through the points 3, 4, and negative 1, negative 1. First thing I need to do is find the slope. Here's the slope formula, y2 minus y1 over x2 minus x1. I'm going to let this be x1 and this be y1, this be x2 and y2. So for my slope, I'm going to have y2 is negative 1 minus y1, which is 4, over x2, which is negative 1, minus x1, which is 3. Negative 1 minus 4 is negative 5. Negative 1 minus 3 is negative 4. The slope is negative 5/4 or just 5/4. Now I'm going to use my point slope formula. Y minus y1 equals m times quantity x minus x1. I know that y1 was 4. I know that my slope is 5/4. And I know that x1 is 3. This is the equation of a line through the points 3, 4, and negative 1, negative 1. But that is in point slope form. The directions wanted it in y-intercept or slope-intercept form. So first thing I need to do is to distribute the 5/4 on the right-hand side. 5/4 times x minus 5/4 times 3. Now I need to move this 4 to the other side to get the y by itself. So I'm going to add 4 to both sides. Y equals 5/4 x, and then negative 15/4 plus 4 gives you a positive 1/4. This is the same line as this. The one on the top is in point slope form. The one on the bottom is in slope intercept form. Number 3, write the equation of the line perpendicular to x equals negative 3 that goes through the point 6, 1. First thing to discuss, a line x equals negative 3, that's a vertical line. So when I graph x equals negative 3, it's a vertical line through the x-intercept negative 3, 0. I want to find the equation of a line that goes perpendicular to that red line that goes through the point 6, 1. So you see that the line I want is going to be horizontal, right here. And the equation of a horizontal line is always y equals a number. And what number will it equal? It'll equal the y-intercept, which is 1. So number 3, the answer is y equals 1. Number 4, it gives me a piecewise defined function. The function is 5x plus 1 if x is less than 1. The function is 6x if 6 is less than or equal to x is less than or equal to 8. And the function is 6 minus 2x if x is bigger than 8. Now, you want to find f of 0. So the question is, where is 0? Is it going to be in the red piece, the green piece, or the blue piece? Well, when you look at a number line, 0 is to the left of 1. So for the x is less than 1, 0 is going to fall in the red piece. 0 will fall in the red piece. That's why I labeled it f of 0 in red here. So you go to your red piece and you plug in 0. 5 times 0 plus 1, the answer is 1. So f of 0 is equal to 1 with this piecewise defined function. Number 5. Given f of x equals negative x cubed plus 4, verbally describe two transformations that occur from the parent function y equal x cubed. If this is the parent function, what are you doing to it to get this? And the first thing out front, the negative out front, reflects it over the x-axis. And the plus 4 out to the side shifts it up 4 units. Number 6. If you have f of x is x minus 5 all over 4, g of x is 7x plus 3, can you find g composed of f of negative 19? By definition, that's g of f of negative 19. So on your f function here in the inside, go to your f. Wherever you see an x, plug in negative 19. So negative 19 minus 5 all over 4 is equal to negative 6. So now you're looking at g of negative 6. Go to your g function. Everywhere you see an x, plug in negative 6. 7 times negative 6 plus 3 is equal to negative 39. Number 7. Find the vertex of y equals x squared minus 16x plus 71. You notice that this is a quadratic function because it's an x to the second power. So quadratics have either a max or a min. Since the a value here is positive, this quadratic is going to open up. We're trying to find the vertex down here. How do you do that? The vertex is always hk. To find h, you use the formula negative b over 2a. Our a here is 1. Our b is negative 16. And our c is 71. So our back to h. H is equal to negative b over 2a. Negative b would be the opposite of negative 16, so 16. 2 times 1 is 2. 16 over 2 is 8. So the x-coordinate of our vertex is 8. To find the y-coordinate, our k, you're going to plug this value back into this function. So you get 8 squared minus 16 times 8 plus 71. When you do that, you get 7. So our vertex is the coordinate 8, 7. Number 8, list the zeros, their multiplicity, and whether the graph touches, squiggles through, or crosses the x-axis at each zero. Here's our function. It's already in factored form, and you can get the zeros by setting each factor equal to 0. So this first one, when I set it equal to 0, I get the 0, x equals 0. You're raising it to the first power, so the multiplicity is 1. And since the multiplicity is odd and it's 1, we know that it just crosses the x-axis at that 0. For the second one here, x minus 5, you set that 0. X minus 5 equal to 0. You solve for you solve for x. You get x equals 5. That's the 0. Since it's being raised to the second power, the multiplicity is 2. Since the multiplicity is even, you know that it touches the x-axis at that 0. For the last one, here, x plus 1 quantity cubed, you set that equal to 0. X plus 1 equals 0. X equals negative 1. That's how you got the 0. It's being raised to the third power, so the multiplicity is 3. It's going to cross the x-axis at x equals negative 1, but it's going to squiggle through. It's not going to be linear because the multiplicity is 3. Number 9. Factor this polynomial given that 1/2 is a 0. So let's go do some synthetic division. Put the 1/2 in the half box. These coefficients go across the top here. Now bring down the 8. Multiply 8 by 1/2 and you get 4. Negative 30 plus 4 is negative 26. Multiply negative 26 times 1/2 to get negative 13. 33 plus negative 13 is 20. Multiply 20 times 1/2 to get 10. Negative 10 plus 10 is 0. Since our remainder was 0, that shows that 1/2 was indeed a 0. Now the polynomial that remains down here is going to be 8x squared minus 26x plus 20. That factors. I can factor out a 2 first, and I'm left with 4x squared minus 13x plus 10. And this factors to 4x minus 5 times x minus 2. So the initial question was to factor this polynomial. I know that x equals 1/2, so x minus 1/2 was one factor. And here's the rest of it down here. And to find the multiple choice answer, you needed to distribute this 2 here. And you get 2x minus 1 times 4x minus 5 times x minus 2. Those are the 3 factors when you multiply together that gives you the original polynomial. Number 10, find all the zeros of the given polynomial if you know negative 4 is a 0. So again, we're going to put negative 4 in our half box. We're going to put our coefficients up here on the top row. Once we do that, we're going to do the synthetic division. Bring down the 1. Do 1 times negative 4 to give you negative 4. Negative 2 plus 4 is negative 6. Negative 6 times negative 4 is negative 24. Negative 11 plus 24 gives you 13. 13 times negative 4 gives you negative 52. 52 plus negative 52 is 0. The remainder was 0, so that did mean, that showed that negative 4 was indeed a 0 of the polynomial. What remains is x squared minus 6x plus 13. Unfortunately, that does not factor nicely. So we're going to have to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So my a is 1, my b is negative 6, and my c is 13. So x equals negative b, 6, plus or minus the square root of b squared, negative 6 squared, minus 4 times a, which was 1, times c, which is 13, all over 2 times a, which was 1. When you do that arithmetic, you get 6 plus or minus the square root of negative 16. And over to the side, the square root of negative 16, to get rid of the negative under the radical, you have 16i, which is 4i. So to go from here to here, that's how I did it. So 6 plus or minus the square root of negative 16 all over 2. I'm going to divide both things by 2, so I get 6 over 2 plus or minus 4i over 2, which is 3 plus or minus 2i. The original 0 they gave you was negative 4, and you just found 2 additional zeros, 3 plus 2i, 3 minus 2i. Something to comment on. These two zeros are called complex conjugates. A plus bi, a minus bi are complex conjugates. And you always have imaginary or complex zeros. They occur in complex conjugate pairs. Number 12. Find the inverse of f of x equals cubed root of quantity x minus 7. First thing you do to find the inverse, you switch the x's and y's. Instead of writing y here, I wrote an x. Instead of writing an x here, I wrote a y. So I have x equals the cubed root of quantity y minus 7. Now I need to solve for y, so I cubed both sides. So that gave me x cubed equals, the cubed root cubed goes away, and I'm left with just y minus 7. If I add 7 to both sides, and I get y equals x cubed plus 7. That is my inverse function. For number 13, graph f of x equals 4x plus 3. Notice that this plus 3 out to the side shifts it up 3. Your parent function, y equals 4 to the x. Your three favorite x values are negative 1, 0, and 1. When x is negative 1, y is 1/4. When x is 0, y is 1. And when x is 1, y is 4. So your parent function, negative 1, 1/4, 0, 1, and 1, 4. Here's your parent function. All of those points we want to shift up 3. So we're not moving the x values at all. Those stayed the same. But these y values, you want to add 3. Add 3 to all the y values. When you do that, 1/4 plus 3 is 13/4. 1 plus 3 is 4. 4 plus 3 is 7. So I have the point negative 1, 13/4, 0, 4, and the point 1, 7. So my graph looks like this. A little extra, the domain is going to be all real numbers. And since we shifted it up 3, the new horizontal asymptote is here at y equals 3. So the range goes from 3 to infinity. Number 14, we want to solve 2 raised to the 6 minus 3x equals 64. I realize that I can write 64 as a power of 2, 2 to the 6th. So I have 2 to the 6 minus 3x equals 2 to the 6th. I'm going to use the rule that a to the m equals a to the n, means that m must equal n. Basically, you can get rid of the bases. So now I have that 6 minus 3x equals 6. To get x by itself, I need to subtract 6 from both sides. 6 minus 6 goes away. 6 minus 6 on the right-hand side is 0. So I have negative 3x equals 0. Divide both sides by negative 3. X equals 0. Last one is number 15. Log base 2 of x plus 3 plus log base 2 of x minus 3 equals 4. I want to get one log here on the left, and I notice that I have the sum of two logs. So I'm going to use the property that log base b of a plus log base b of c is equal to log base b of a times c. You're multiplying the two arguments. So when I multiply the two arguments here, I get log base 2 of x plus 3 times x minus 3 equals 4. Now I want to convert to exponential form. 2 raised to the 4th power equals x plus 3 times x minus 3. 2 to the 4th power is 16. When I FOIL the right-hand side, I get x squared minus 9. Then I added 9 to both sides, and I got 25 equal to x squared. To solve for x, I took the square root of both sides. On the left-hand side, I have plus or minus the square root of 25. So I get that x equals plus or minus 5. When I plug in negative 5 for x, right here, back into my original equation, when I do that, the log of negative 5 plus 3, log negative 5 plus 3 gives me the log base 2 of negative 2. You cannot take the log of a negative number. That doesn't work. That's not real. You can't do it. So I have to cross out negative 5 as an answer. The only answer that works is x equals 5. I know that was fast, but there were a lot of problems, and I wanted to do the video as quickly as possible. Hope you get something out of it.